Hello everyone, my name is Kanika and today we will be talking about an extremely interesting topic from grade 9, that is probability. So we will talk about the basics of probability, what probability means, what's the definition, how do you get it, how do you solve the questions related to it, and we will be talking about various events such as rolling a die, and then it could be playing cards. So let's understand them one by one. Let me share my screen with you. All right. So this chapter basically consists of 3 to 5 marks in the CBSE exam, which is again a very good marks for it, right? So we will be understanding this chapter. Let's look at the things which we will be learning. So first thing we will be talking about it, an experimental approach, as in what's the probability, how do you do it. Then we will be talking about an empirical approach. Before starting, I just want to tell you one thing, like there are two types of probabilities, theoretical and experimental. So experimental approach is same as that of empirical approach. So let's understand them one by one. So what do you understand by the probability? The basic definition. Like for example, suppose a shopkeeper wants to buy some sugar. So by he has to buy some quantity, so what quantity he should buy so that the sugar is completely sold off, like he has to estimate the quantity, right? That depends on the previous quantity or the previous month's sale. So if I say he has sold 10 kgs previous month, so he would be either taking 10 kg or somewhere around 10 kg, right? Let it be 11. Now, there might be a possibility that he will get something, he will be left with some quantity, or he might be able to sell all of them. So, this is basically the probability. This is a position of uncertainty. So, in case of uncertainty, when you provide numbers to it, when you provide such situations with the numbers, or when such uncertain situations are represented using the numbers, then this possibility or this branch of math is known as probability. So let's look at the definition. Probability, a branch of math that deals with likelihood of the occurrence of the given event. Like how many chances are there that a particular event will occur? For example, if you have tossed a coin, so there are two possibilities: either you get a head or a tail. So in case of this, like this is an uncertain event, like either you get a head or a tail. So when you provide the numbers to such situation, like probability of getting head would be 1 over 2, like one chance is head out of the two. Similarly for tail it's 1 over 2, because it's you get only one times tail out of two chances. So again the situation is uncertain, but we have represented these values with the numbers, so this is known as probability. Now probability numbers lies between 0 and 1. You cannot have probability less than 0 and cannot have it greater than 1. So also it cannot be a negative value. It's very important point. Next, the basic rules such as addition, multiplication and complement are associated with the probability. So this is the case of or, and not. Now, how do you represent the probability? So probability of an event E is given by number of favorable outcomes by total number of outcomes or total number of possible outcomes. Like for example, if I say that there is an event of rolling a die. Now we know that on a dice there are six numbers: 1, 2, 3, 4, 5, and 6. So if I want to find out the probability of getting an even number. So how many even numbers are present? 2, 4, and 6. So there are 3 favorable outcomes for each. So I'm connecting this example with the definition. So total favorable outcomes you have 3, and total number of possible outcomes you have are 6. So probability of getting an even number would be equal to 3 over 6, which is equals to 1 over 2. So this number is less than 1. That means the probability lies between 0 and 1 only. It could be equal to 0, it could be equal to 1, but the value of the probability lies between 0 and 1 only. Let's look at this diagram. So when you start with 0, this is the case of 0. So impossible event. For example, getting uh, getting a number 7 on a dice. Not possible. So total favorable outcomes are 0 in this case. So 0 by 6 is known as impossible event. Next comes unlikely event. Unlikely means 1 in 6 chance. As in, what is the probability of getting a number 2 on a dice? So there is only one chance out of 6. So you have the probability as 2 over 6, that's 1 over 3. Sorry, not 2 over 6, it's 1 over 6 because there is only one number 2. So probability becomes 1 over 6. So this is unlikely. Next comes even chance when both of them have a 50-50 chance. Like in case of a coin. Either you get a head or a tail. Both of them has a 50-50 chance. So this is known as even chance. Next comes likely. Likely means when they have the majority of chance, like 4 and 5 chance. For example, getting let's say getting the number less than 6 on a dice. So there are 5 numbers which are less than 6. So this would be 5 out of 6. That means a fair chance. And if we talk about even chance, so getting an even number. So probability is 1 by 2, right? Next comes certain event in which the probability is 1. That means uh, if we talk about the certain event, that means the numbers which are equal to or less than 6 on a dice. So all of the numbers are less than 6 and equal to 6 as well. So this would be 6 by 6. That means you get a certain event which is equals to 1. So if we talk about the percentage in this, so impossible event is 0%, then this would be 25%, this would be 50%, this would be 75%, and this would be 100%. So these are the possibilities, and this is how you explain the probability with this diagram. Got it? Let's move further. Let's take a question. So there is a container full of colored bottles, red, blue, green, and orange. Some of the bottles are picked out and displaced. Sumit did this 1000 times. 1000 times is the total number of possible outcomes. And then number of blue bottles picked out are 300, red bottles 200, green 450, and number of orange bottles are 50. Now, what is the probability that Sumit will pick a green bottle? So, as we discussed in the definition is total number of outcomes, favorable outcomes by total number of outcomes. So, favorable outcomes for green bottle is 450. So, this would be 450 over total, that's 1000. So you can cancel out zeros, 45 and 100 gets cancelled by 5, you get 9 and you get 20. So probability comes out to be 9 over 20, which is less than 1 again. Next is, if there are 100 bottles in a container, how many of them are likely to be green? So now you have to find out the ratio first with respect to the given question, and then you need to multiply it with 100. It's like unitary method. So you have 9 over 20 into 100. So zeros gets cancelled. 2 and 10 gets cancelled by 5, you get the result as 45 bottles. So this is how we solve this question. Let's look at the answers given. The first is 0.45, or you can simply write it as 9 by 20 as well. That's the same thing. Then you have experiment implies that 450 out of 1000 bottles are green. So out of 100 bottles, it would be 45. All right. Now let's move to the experimental approach. First of all, let's understand what experiment means. Let's say I am tossing a coin 1000 times. So this is known as experiment. In an experiment, there are two types: probabilistic and the second one is deterministic. So deterministic experiment means whose result is already known to you. Like for example, if we talk about any science experiment, it could be. Let's say I'm burning a magnesium ribbon. We know that we get magnesium oxide only every time. So result is already known to you. That means it's a deterministic experiment. And if we talk about the probabilistic experiment means whose result is not known to you beforehand. For example, let's say tossing of a coin. So either you get a head or a tail. Result is not known to you. And even if you toss the coin 1000 times, you get 1000 different results, either a head or a tail. So experiment is of two types, probabilistic and deterministic. And we will be talking about probabilistic experiment. Now let's move to the definition again. Experiment means it's a series of steps followed to get some result. So now if we talk about 1000 times, 1000 times 1000 tosses. So either you get head or a tail. So basically, we have done 1000 steps to reach to complete an experiment. And each step is known as trial. Each toss, in this case, it's each toss. So each toss is known as trial. Now, if we talk about the experimental approach means we are taking care of the complete experiment. Now let's look at the definition. An experiment is repeated a fixed number of times and each repetition is known as trial. Mathematically, the formula for experimental probability is defined by number of times an event occurred divided by total number of trials. It's the normal definition only. Like for example, in this, they have taken a coin which is tossed 10 times and head is recorded 7 times, tail is recorded 3 times. So probability of getting a head would be 7 upon 10. That's the required event. This is the total number of trials. Similarly for tail, it would be 3 over 10. All right. Now, as I told you that probability cannot be greater than 1. So the probability associated with a single event, this is a single event, as in single experiment, when you add them, you get the result as 1. You cannot have probability greater than 1. All right. Now let's move further for the next part. Let's look at this question. So in this, a bag contains 10 red marbles, 8 blue marbles, and 2 yellow marbles. Find the experimental probability of getting a blue marble. Now, in this case, it's like information is not complete as of now. So you have to assume things. Let's assume that we have done the experiment 10 times, for example. And out of that, you have taken out the blue marble 6 times. Since no information is given, that is why we are assuming it. So blue marbles we have taken out as 6. So probability of getting a blue marble would be equal to 6 over 10. That's 3 over 5. You can assume any number, 20, 100, that's your choice. All right. So this is the example they have taken. Take a marble from the bag, record the color and return the marble. Since it's not written that, you have not replaced that marble. So you have to obviously put back the marble again in the bag. Now repeat a few times. So they have taken it as 10. Count the number of times a blue marble was picked. So it is 6. Experimental probability of getting a blue marble would be 6 over 10. That's 3 over 5. Now one more thing, as we discussed that probability lies between 0 and 1. So let's take n as the total outcomes, m as favorable outcomes, the probability of event E would be equal to m over n. Now, m cannot be greater than n, but it could be less than or equal to n and less than or equal to 0, right? So that means if I take this to the other side, so we are left with 0, m over n and 1. So m over n can be represented with probability of event E. So this shows that probability of event E lies between 0 and 1 only. Also, one more thing, that probability of event E plus probability of event not E would be equal to 1, as in sum of all the probabilities of one single experiment is equal to 1 every time. And not E means, let's say for example, if we talk about probability of getting ahead is equals to 1 by 2. Now probability of not getting ahead, that means it's a tail, is again 1 by 2. So you have, this is PE and this is P not E. So this would be equal to 1 by 2 plus 1 by 2, which is equals to. Got it? Let's move further. Next is empirical probability. So empirical probability is also known as experimental probability. It is referred to the probability that is based on historical data. In other words, empirical probability illustrates the likelihood based on historical data. So basically, empirical probability is related to an experiment, complete experiment, as in number of favorable trials divided by total number of trials. So probability of E is given by F over N. You can take any variables as of your choice. Also in the starting, I talked about theoretical probability as well. So theoretical probability is always related to a single trial. So number of favorable outcomes in a trial divided by total outcomes of a trial. Let's understand this in detail. Like if I talk about tossing a coin 1000 times, out of which 700 is head and 300 is tail. So probability of getting a tail The experimental probability would be equal to 300 over 1000. That's 3 over 10. And if we talk about the theoretical probability, so theoretical probability means tossing a coin one time. So probability of getting a tail would be 1 by 2, which is related to only single trial. And experimental probability is related to the whole experiment. That's the basic difference. Now let's look at this question. Calculate the empirical probability of an event wherein 40 is the frequency of class and 120 is the total frequency in the probability distribution. So favorable frequencies are 40, total frequencies 120, and probability would be equal probability of class, I should say, is equals to favorable over total. That would be 40 over 120. So this would be equal to 1 by 3. So this is your answer. Yeah. It's not necessary that you need to convert it into decimal. You can leave your answer as fraction as well. This is also fine. 1 by 3 is also fine. That's your choice. All right. Next example questions. You asked your 3 friends, Sakshi, Shreya, and Ravi, to toss a fair coin 15 times, each in a row. And the outcome of this experiment is given below. Calculate the probability of occurrence of heads and tails. So when Sakshi tossed the coin, number of heads are 6, number of tails are 9. Total comes out to be 15. Shreya, number of heads 7, number of tails 18. 8, sorry. Again, it is 15. And then 8 and 7 by for Ravi, it is again 15. Now probability of getting head and tail. So this would be 6 by 15, 9 by 15. Then this would be 7 by 15, 8 by 15. This would be 8 by 15 and 7 by 15. Let's look at the answer. So you can convert it into decimal, or you can simply leave your answer in the fractions as well. That's your choice. Next question. The empirical probability, the table shows a dice thrown 3 times and the corresponding result. What is the empirical probability of rolling a 4? So there is no 4. That means the probability of getting a 4 would be 0 out of the total. The total is 2 plus 5 plus 1. So that is 8. Answer is 0. So this is an impossible event. So you get the result as 0. So it's 0%. So I hope the basic parts are clear to you. With this, we completed the first part of the chapter. In the next few slides, we will be talking about cards, coins, and dice. Thank you so much and stay safe. Thank you.